Okay, so the cool thing about this lesson, factoring a difference of squares, is that it's meant to be a very quick and fast factoring, and you're using square roots. So, before we get into that, I want you to look at this first 3 bullet points as a review, okay? So when we do double distribution, we get x times x is x squared. X times minus 4 is minus 4x. Then 4 times x is positive 4x. And 4 times negative 4 is negative 16. Well, if you notice, the 2 middle terms, negative 4x and 4x, eliminate each other. So the final answer is x squared minus 16. Now we actually call this a difference of squares. Why? Well, because it's subtraction. And x squared, well, that's a perfect square because it's x times x. And 16 is a perfect square, which is 4 times 4. That's where the square roots come in play. Because today we're going to start with this as our problem, and our final answer will be the x plus 4 times x minus 4. Now, I could even do the full double distribution for these last 2 bullet points, but hopefully you'll get to the point where you can recognize, oh, guess what? There's a pattern. All that's different is the sign, they're opposite signs in each of the factors for the second term. So x times x is where you get your x squared, and then your positive 4 and your negative 4 is where you get your negative 16, and the middle terms eliminate each other. Always. Always the case because of the plus and the minus. That's a never fail. So I'm not even going to do the full double distribution for these last 2 bullet points. Because I see the plus and the minus, I basically recognize that the middle terms will eliminate, so I just do 5x times 5x, which is your 25x squared, and then the last 2. So positive 1 times negative 1 is minus 1. But there's your difference of squares. Difference because it's minus, squares because x squared is a perfect square, and 1 is a perfect square. So for the last one, we do the same thing. All I notice is that the only difference between the 2 factors that we're multiplying is one has a plus 3b and one has a minus 3b. That's it. The first terms are exactly the same, and we just have the plus and the minus of the last 2 terms. So I know the middle terms are going to cancel, so I'm just going to do 2a times 2a is 4a squared. And then 3b times negative 3b is minus 9b squared. So if we're just going from this direction as the problem, and then these will be our answers, all you're doing is square rooting each of these into the 2 factors, and then you have your plus and your minus. Well, if you look at number 1, I can automatically go to the final answer. I know there's a plus and a minus, and I basically just split up the perfect squares. So a squared is a times a, and 4 is 2 times 2, so I've got my final answer. Okay. Now the order matters. So like in number 3, I know both 81 and x squared are perfect squares, and to get that minus I need a plus and a minus. The 81 comes first, so when we square root 81 and get 9 and 9, both the 9s need to come first. And then to get the minus x squared, I split up into positive x and negative x. And if I did the full double distribution, I would get this back. Now look at number 5. If I have k squared plus 25, there's no way I could have a positive times a negative to get a positive, or there's no way I'd have 2 positives so that the middle terms do not eliminate. So guess what? Anything that has 2 terms, even if they're perfect squares, but they're both positive, it's prime. The only way this shortcut works is if the first one's positive and the second one's behind the minus or negative. remember, when we did the double distribution, we had the negative 4x and the positive 4x that eliminate each other. That's the only way we had two terms left, because a difference of squares is a binomial for the multiplied out version. Okay. So like number 7, we separate this. Will 9b squared? Oh, well, first we have our plus and our minus because of the two terms with the negative. And the square root of 9b squared is 3b. So we put the 3b first. And the square root of 100 is 10. So we have the plus 10 and the negative 10. And that's where we get our negative 100. Now, it also works with two variables. So if you look at number 11, right away, I can do this because of the minus with the two terms, and they're both perfect squares. I can square root them. As long as you can square root both terms, this works. And you have your plus and your minus. The square root of 4h squared is 2h. So I put a 2h in the front. And the square root of 25g squared is 5g. And since I already have that plus and the minus, that's where I get the negative 25g squared. And if I was to fully double distribute this out, the middle terms would eliminate like it did up there. Now, 13, it works the same exact way. X squared y squared is a perfect square. Anything with even exponents is going to be a perfect square. And we can square root 1. The square root of 1 is 1. So we just separate. We have the plus and the minus. The square root of x squared y squared is just xy and xy. And the square root of 1 is 1. So we have the positive and the negative 1. And we would be able to double distribute that out and get the x squared y squared minus 1. So with other even exponents. Like look at number 17. Oh wait, let's do number 15 first. Notice this. Everything except that 5 is not a perfect square. So guess what? This is prime. Even though it was minus, and even though we have, like I could square root 4c squared and the d squared, I cannot square root the 5 into whole numbers. Okay. Now algebra 2, it might be useful to separate into radicals, but don't worry about that right now. For now, just know that it's prime. But like for number 17, as long as you have even exponents on the variables, because remember from our exponent rules, when you square root exponents, you basically separate them, divide the exponent by 2. So here, k to the 6th, I'm going to separate into k to the 3rd times k to the 3rd. And then we have our plus and our minus, 4 and negative 4, and we're done. And then 19, well, the square root of 121r to the 6th is 11r, and then the minus 1 is going to be your plus 1 and your minus 1 to fully factor. The first step is always going to be looking for a GCF, but remember we call this an overall when we're looking at all the terms. And then you just factor using, like in this case, since there's two terms, we're looking for the difference of perfect squares. So, looking at number 21, well, the overall GCF between both terms, they don't share the same variable, so we're just going to look at the coefficient. So 24 and 54, they have a GCF of 6. So we're going to divide out a 6, and we get, what is that, 4a squared minus 9b squared. And then each one of those are perfect squares. I can square root 4a squared, and I can square root the 9b squared, and I have the minus. So right away, don't forget your overall GCF. We're going to go right into the factoring shortcut for difference of squares. The square root of 4a squared is 2a. And then the square root of 9b squared is 3b, but we need the plus 3b and the negative 3b, and we're done. So to work backwards, if you check this, you would want to do the double distribution between these two, then distribute the 6, and you should get the 24a squared minus 54b squared back. Now, let's skip to number 27. Okay, already, if you look at the coefficients, I know they both, 8 goes into 32 and itself, and they both have at least one y. So the overall GCF in this case is 8y. So the reason why I write this out is just make sure that your final answer has the overall GCF out in front. Otherwise, it's not complete. It's not a correct answer. So when we reduce this, I get x squared minus 4y squared. And right away I recognize it's a difference of two squares, which I can square root both. So I go straight to the final answer. Don't forget the 8y in front. Sorry, I'm kind of writing big. So I can split the x squared into x and x. And then the square root of 4y squared is 2y. So I have my plus 2y and the minus 2y, and there's your final answer. So again, these are meant to be quick. Now, actually go ahead and try these on your own, and then check the answer key.